Alright, hi guys, we're going to start talking about graphing rational functions. So there's a few things that we need to find before we actually graph the rational function. We need to find the y-intercept, the x-intercept, the vertical asymptote, the horizontal asymptote, and points in the region. And we'll talk about each of those as we do the examples. Alright, so let's move on to our first example. Here we go. So the first thing that we need to find is our y-intercept. And if you remember, to find our y-intercept, we're going to plug in 0 for x. So we have f of 0 equals 1 over 0. Well, if you remember, 1 over 0 doesn't exist because anything over 0 just does not exist. This doesn't exist. Alright? And we'll get back to that, but we'll say that x cannot be 0. Alright, and then we have our x-intercept. And to find x-intercepts, we would try to solve by putting our function equal to 0. But the nice thing about rational functions is that we can set the numerator equal to 0. So in order to set our numerator equal to 0, we would have 1 equals 0. Well, we know that our numerator will never be 0, it will always be 1, so we will say that y cannot be 0 as well. Okay, so now we have our vertical asymptote, and with the vertical asymptote, what this means is like it's an invisible line that our graph will never touch. Well, and we kind of already found them with our x and y intercepts. So a vertical asymptote will always deal with the x value. So this is whatever x value does not equal a, and that's just a variable. So we've already discovered that x cannot equal 0, so we have a vertical asymptote right here at the y-axis. And it's just that invisible line that our graph will never touch. And then we have the horizontal asymptote. And this deals with the y values. So y cannot equal b. Alright, so y can't be some number. And we've already figured that out from our x-intercept. And it will never be the x-axis. Not a great line. Here we go. So it'll never be either of these axes, okay? So then we have the points in the region. So the points in region, basically what this means is we need our part of our graph in the left region and then part of our graph in the right region. So we can find this by plugging in some x values. So the x values, I'm going to use are 1 and -1. So we're going to find f of 1. So f of 1 is 1 over 1, and that's going to equal 1. So we have the point 1, 1. So that's our right point. And then with our left one, we have -1. And then 1 over -1, that's going to be -1. So we have 1, -1. So we have our 2 points. So we have a point right here, and then we have a point right here. Alright, so then from here, we can graph our function. So we're going to have a graph like that, and then a graph like that. And our line will get really close to the x-axis but never touch it, and then our line will get really close to the y-axis and never touch it. So that's what those asymptotes are for. So let's move on to the next example. So now we have f of x equals 3x plus 6 over x minus 1. So then for this one, our y-intercept, as we did before, we have to plug in 0 for x, so we're going to have 3 times 0 plus 6 all over 0 minus 1. That's going to be 0 over -1. I'm sorry, 6 over -1. And then we have -6 as our y-intercept. And I'm just going to go ahead and graph that point. So we have 0, -6. Alright, and then our x-intercept. We need to plug in, or we need to have f of x equal to 0, but what we can do is we can solve the numerator for 0. So we're going to have 3x plus 6 equals 0. And then solving for x, we have 3x equals negative 6. And then we have x equals negative 2. So our point for this one is going to be negative 2, 0. So negative 2, 0. And y-intercept, if you didn't know, is 0, negative 6. Alright, so now our vertical asymptote. So now for our horizontal asymptote, we're going to do something a little bit different. Up here I have some facts about asymptotes. And right here, this is a general rational function, so don't worry about that. It's a lot of variables. So if we can satisfy any of these conditions, it has an asymptote at wherever. So the graph will have a vertical asymptote, blah, blah. Okay, so we don't have to worry about that one. We're looking for horizontal asymptote. So we're going to look at 2, 3, and 4. So 2, if n is greater than m, then the x-axis is the horizontal asymptote. So n and m are the exponents on x. Well, they're both 1, so fact 2 doesn't have anything because, fact 2 doesn't have anything to do with this. So if n equals m, then the line a over b is the horizontal asymptote. Well, n and m equal each other because 1 equals 1, so we have a over b is going to be the asymptote. A and b are the coefficients of x. So we have 3 over our 1, and that 1 is implied because 1 times anything is itself. So we can go back to here and say that n equals m. So 1 equals 1. And then we have our asymptote of y equals a over b. And a over b is 3 over 1. So we have a horizontal asymptote at 3. So I'm going to go ahead and draw my asymptote at 3. So we have our asymptote at 3. So lastly, we have our points in regions. So we have our left side already done with our x and y intercepts. So now we need to get our right side region. So I'm going to put a positive 2 because 2 will be in our right side. And it's not 1. So I'm going to put 2 into the x. So f of 2 equals 3 times 2 plus 6 over 2 minus 1. Then we have 6 plus 6, and that's 12 over 1. So we have 12. So we have a point at 212. So we can't see this point, but we know it's all the way up here somewhere. But I'm going to go ahead and graph my function. So it's going to look something like this. Something funky like that. But there you go. We have our rational function. So now let's do our last example. We have f of x equals 9 over x squared minus 9. So y-intercept, we need to plug in 0. So do that real quick. So pause the video here and find the x-intercept. So for your x-intercept, you should have gotten negative 1. So we're going to have a point at 0, negative 1. So I'm going to plot that real quick. All right. So then, oopsies, that's supposed to be r. So you have 0, negative 1. Alright, so then we have our x-intercept. So remember, you're going to put the numerator equal to 0. So find what your x-intercept is. So pause right here and find your x-intercept. So if you set your numerator equal to 0 and it's just 9, you're going to have does not exist because 9 will never be 0. So it does not exist. We do not have a x-intercept. So then moving on to our vertical asymptote, we need to set our denominator equal to 0. So I want you to set your denominator equal to 0 and find the vertical asymptote. Alright? So pause your video here and find the vertical asymptote. So if you did this correctly, you should have gotten x cannot equal plus or minus 3. So we have two vertical asymptotes. I'm going to graph them for you. So we have one at -3 and +3. So yes, you should have two vertical asymptotes. Now you need to find your horizontal asymptote. So for this one, I would recommend that you use the asymptote facts. So I'm going to scroll back up to the asymptote facts, and then you will find the horizontal asymptote. So pause your video here so you can use these asymptotes to find the horizontal asymptote. So if you used your asymptote facts, you would have recognized that m is greater than n, m being the exponent here and n being the exponent here. So 2 is greater than 0, so we have a horizontal asymptote at the x-axis. Alright? So now for the points and region, we have three regions. We have the left region, we have the middle region, and we have the right region. We already have a point for the middle region, and we know it's going to go down because of that horizontal asymptote. But now we need to find the right region and the left region. So for the left region, you can choose any point, but I would prefer you use, I'm going to use -4. And for the right region, I'm going to use f of +4. So once you find those points, graph them. So pause the video here and find those points. So if you did this correctly, you should have gotten 9/5 for both -4 and +4. So I'm going to go ahead and graph those points. I'll write them real quick right here. So then -4, 9/5. So our point is right here, and then 4 here. And then our graph will look like this. So now I want to take you to Desmos to show you how that we could use Desmos to graph. So this is back at example 2. We had 3x plus 6x minus 1, and we're going to go ahead and graph that. So if we look here, it gives us the y-intercept, and it also gives us the x-intercept. And then we had to find our asymptotes, but you could also find them by seeing how close it gets to some number. So we can see that it gets really close to 3, but never, really gets there. And then same with 1. It gets really close to 1, but it really never gets there. So I went ahead and graphed those, and I could see that it never touches those lines, but it gets them really close. So that's one way that I want you to graph with Desmos. So then we have our last example. We had 9 over x squared minus 9. So I'm going to go ahead and graph that. And you can see it has those multiple regions. And then we knew that we had asymptotes at 3 and -3. So we can see that our functions get really close to 3 and -3, but never actually touch them. And then same with the x-axis. It gets really close, but it never actually touches them. So please be aware of knowing how to do it by hand and on Desmos. Desmos is a great way to check your work as well. So that's it for today. Have a great day and stay safe out there.